What is up, guys? Nitty Gritty Maths here. Today we are going to show you how to do local linearization or the tangent line approximation. And we're just going to start off with the equation. It looks a little daunting and I don't blame you. And we're going to start it off. There's a lot of variations to this equation, but what we have here is the line of local approximation, the tangent line, and we are going to denote this as this way. So it may not look as familiar to you because you might have seen it in a different way, but this is usually how it is denoted. So we are going to use this, and your A here is going to be your original point, and your X is going to be the one you're trying to get the approximation for. So we're going to try to do some examples with you guys and help you out. So we're going to start it off, and the first question here is going to be find the local linearization of f of x equals the square root of x at x equals 4, alright, and then approximate the square root of 4.1. So what we got here, we got a function. We're going to find the local linearization at a point. Pretty easy, just find the tangent line, and the approximation is where people get kind of iffy, but I'll show you how to do it. So first we're going to solve for the actual point. So we'll use the function f of x equals the square root of x. We'll plug in our f of 4, get square root of 4, and that will be equal to this 2. So we get a point, 4 comma 2, that's one of our points. Then we're going to solve for the tangent, or the slope of the tangent line. So the slope of the tangent line is just the derivative of the function, which is 1/2 x to the neg 1/2. Alright? And then we can simplify that down. We get 1 over 2 square root x. And we plug in the x that we got here, the x equals 4, we'll use the m tangent equals 2 over the square root 4. We use this to get the slope, and we will get 1 over 4. Since the square root of 4 is 2, we will get 1 over 4. We have our slope, we have our point, now we can get our line. So we will use y minus y1 equals m x minus x1, and y minus 2 equals 1/4 x minus 4, and as we distribute and add, we will get in a final answer of 1/4 x plus 1. So it makes sense when you graph it out. You'll get your graph here, and you will get, since it's the positive square root x, you will get a graph like that at x equals 4. That line right there, we'll use a different color here for you guys. That line there is going to be the 1/4 x plus 1, and I can verify that using a calculator as well. And we've got it all here at Nitty Gritty Maths. I'll tell you that. I mean, we go some long strides. And I'll show you square root of x. Let's see, the square root of x, and we will graph our 1/4 0.25x plus 1, our tangent line at 4. We are going to adjust our window as well, put it 0 to 4, and our height can be 0 to whatever 3, and we will graph it. We will get the blue function there is going to be the square root of x, and the red there is going to be the tangent line, as you can see, at 4. And if we adjust our window, we can see at 5, and then we will graph it once again. The square root of x is blue, the tangent line is red, right there at x equals 4, that tangent line is there. Alright, so I'll show you another one. And the more examples of this is using trigonometry, and I mean, a lot of people are iffy using trig, and me myself, I mean, I'm okay using the trig functions, but sometimes you gotta approximate these weird, just look at this with me. Sine of 187 degrees. You know it off the top of your head? Yeah, me neither. Alright, so what we're going to do here, we're going to use a known fact. What's the closest function or the degree that we know that sine is equal to? So we'll use 180 degrees, and which is equal to 0, alright? And we are going to use the equation that I showed you in the beginning of the video. The L of x is equal to, as we can show the equation once again here, right there above, and it's the f prime of a times x minus a plus a. So a being our original, and in this problem we will use L of x, and that is going to be our sine of 187 degrees, but we don't want to use 187 degrees in calculus. We like to use radians, so we'll use pi over 180 just to convert to radians. And here we'll start with a first, a being our 180 sine of 180, and we'll convert that to radian as well, which is 180 pi divided by 180, which will still be pi, so we'll use pi instead here, and we'll put this over there. We'll get f prime of a, which is just the derivative of sine of pi, which is going to be cosine of pi radians, times x minus a, x being our degrees, our original angle, minus that angle that we know the value of, so that'll be our 187 pi minus 180, and we can just use 180 pi minus 180 to make the subtraction a little bit easier for us. So we'll use sine of 187 pi over 180 equals sine of pi, we already know is 0, so we'll use 0 plus cosine of pi is going to be -1, so we'll plug that in, use a parentheses, and 7 pi over 180. Then we will just use sine of 187 pi over 180 will equal to -7 pi over 180. And as we can plug that into the calculator, that is going to give us a very close result to the actual answer. And all of these are approximations, and we cannot say that they are the actual answer. So we're going to plug it into our calculator here, our trusty old calculator. And let's see. We got radians. I'll just change it to degrees since it will make it easier for the calculations. And we'll use sine of 187, which is negative. This is the actual answer, and we'll write that down. So I'll write the actual answer in red. So we'll say the actual answer. Oh, that's horrible red right there. Actual answer, which is -0.1219. Alright, we got that. We'll use 4 decimal places. Then we'll use -7 pi, 7 on pi. Alright, we'll get the pi in. Hopefully we can. Pi divided by 180, and it would be negative. And we get that answer right there. I'll write it down for you. So this is approximately -0.1222. So we are really close to the actual answer, and to be precise, we can subtract and see that we're actually not that far away from the actual answer. And let's see right here, we are like maybe 3/1000ths of the from the actual answer, and that's really good approximation there. This is why we use this method to use other known values, such as the sine 180 equals 0. We'll plug that into this equation, or you can use a different variation of this equation, which I don't like to use, to be honest, but they all do the same function. Y equals f of the original point times the change in x minus the f of the value of the original point in the function. So that's what we have here, and that's the end. If you want more stuff like this, tell me down in the comments, and I hope you learned some more calculus than you knew before. This is local linearization. I'll put some questions down in the comments, maybe in the description, and I'll post some answers. So that's the end. Thanks for watching. Nitty out.